Okay, so we've been talking about vector equations of lines and parametric and symmetric. Well, now we're going to talk about vector and parametric equations of a plane. Okay, of a plane. So here's a line. And here's a plane. So do you see how a plane is defined by two vectors? Okay, keep that in mind. In order to create this plane, I have two vectors. Okay. All right. So how many points lie on the line? How many points lie on the line, guys? What do you think?
Infinite.
Yes, infinitely many, right? How many points are needed to define a line? Well, to define a line, we need, two. We need a direction vector. So in order to get a direction vector, you only need 2 points. How many lines lie on a plane? So here's a plane. Well, this could be a line. This is a line. I've got lines everywhere here. So what do you think?
Infinite.
Yes, infinitely many. And how many lines are needed to define a plane? What do you guys think? How many lines do you think are needed to define a plane?
2.
The answer is 2. 2 lines. Because do you see how these two vectors here are defining this plane? Okay, so 2 lines to define the plane. All right, so a line is described using a position vector and a direction vector, but a plane is now described using a position vector and 2 direction vectors. Okay, again, because we want to define the plane. Okay, notice here, P naught P is the resultant, right, of M1 plus M2. Okay, sorry guys, just give me 1 sec. My son is having a hard time getting into his class. Give me 1 sec. Just read over this. Okay, just give me 1 minute. You're gonna fill that in? Okay. Okay. Okay, guys, I'm back. You got in. All right. So a vector equation for a plane can be determined giving any of the 2 following scenarios. So a line and a point, but that point cannot be on the line. So the reason that that point can't be on the line is because I have to be able to define the plane, right? So imagine it like 2 vectors. And so I need 2 direction vectors there. So I can't have a point on the same line because then I won't be able to get 2 direction vectors. Okay? 2 lines parallel or intersecting, but not coincident. Again, because I need to find 2 direction vectors. Or 3 points, because from 3 points, I can get 2 direction vectors. Are you guys still with me? I didn't lose you guys, did I?
We're still
No.
no.
Excellent. Okay, good. Excellent. Okay, so we label a plane using pi, just as a line is labeled L. Okay, so we use pi to label a plane. All right, so let's take a look here. So there's my plane in blue. Notice we have position vector that gets me up there. And then I have that P naught P. Well, P naught P is the resultant of vectors A and B. And so I have S times A, direction vector A. So that's just a scalar. And here's another scalar times B. And this is how we define a plane. Okay, so A and B are direction vectors, R naught is a position vector. Okay, S and T we call parameters. So a vector equation of a plane looks like this. You're going to have a position vector, and then you're going to have two direction vectors. And notice we're using two different parameters because we have different scalar multiples, right? They don't necessarily have to be the same. We know that S and T can be different. Okay, parametric equations of a plane. It's the same like before, guys. Just solve for X, Y, and Z. Okay? From coordinates. Are there any questions?
Miss?
Yeah.
What if the two direction vectors are parallel?
Then you can't define the plane,
Okay.
right? In order to define a plane, they can't be.
Oh.
See that? Cool. Okay, so let's take a look. Simplify the vector equation if possible. Find two other points on the plane. So here is my vector equation of a plane. How can I simplify it?
Reduce the first direction vector.
Okay, interesting. So you want to reduce this one?
Oh no, the second one.
Oh, the direction. Yes, good. Not the position. We don't touch the position. Who can tell me why? Why can't I reduce this one?
Because there'll be a different reference point. And different
Exactly. So that first position vector is what gets me onto that plane. Yes. And so I need that magnitude to remain the same. So I can't reduce that. However, the direction vectors I can. So I can reduce this one, as Brian said. And I can, oops, plus T. And I can also reduce the second one. So what can I write here? Well, I can multiply everything by 2, yes? And both S and T are elements of real numbers. Now I want to find two other points on the plane. So what should I do? If I want to find 2 points on the plane, what can I do?
random numbers of S and T.
Yes, very good. Just random numbers of S and T. So I'm just going to choose let S equal 1 and let T equal 2. And just sub in, and you'll get your points. And now I'm multiplying everything here by 2. And then just simplify this. So I have 2 plus 1 plus 2, 2 take away 1 plus 8, and 4 plus 3 minus 4. Cool? So there's a point on my line. And now I want another point on my line. So I don't know. What do you guys want to let it? Sorry?
Miss, for the points, so you can pick like anything?
You can pick anything. You can let S and T equal whatever you want. You can even let S and T equal 0.
Wait, why?
Wait, those can be 0?
Sorry?
So like for this one, T can be 0, but for the other one, it can't?
No, you can choose one of them to be 0. Not both, but you can, if you want, choose one of them to be 0.
Oh, okay.
Yeah, you're okay. Not both, because then you're going to get the same point, right? But you can let S equal 0, let's say here, and T equal 1, just to find your point, right? Because you're just finding a point. So as long as you have one direction vector, you're okay. What was it? Cool. There's another point.
Cool.
Note, as I already said to you, wrong, wrong, wrong. Don't reduce your first vector. Okay, you need that magnitude. The position vector, you need it to have that magnitude to get you onto the plane. Otherwise, you're not going to be on the proper plane. Okay? Okay, example 2. Find the vector equation of the plane passing through these points. So now I have 3 points. I have to define a plane. So what do I need? To define a plane, I need
Vector.
excellent. I need 2 direction vectors. I need a position vector. No big deal. I've got 3 points here. So let's find some direction vectors. So you can find whichever ones you want. So I'm going to find AB, and that's going to be my first direction vector. So finding AB, it's 2 take away 2, -2 minus 1, and 0 minus -3. There's my
Yeah.
first direction vector. Yes, tell me.
Can I ask a question about the previous question?
Yeah.
So if we simplify S and T,
S and T. Yes.
so theoretically, if we sub in, let's say S equals 1 and T equals 1, right, into the simplified equation,
Into this. Yeah.
we'll get a different answer than if we sub in S equals 1 and T equals 1 into the original equation. So
Yeah,
like,
but that's okay. You're still getting a point on the line. Because remember, it's kind of like that idea. Let's go back to 2D space because it's easier to see it that way. It's that idea of when you're using multiples of the slope, you're still getting on the line. You're just going to be at a different place. So if I reduce it, but then let's say I divide everything by 2, but then I take the S and I multiply by 2, I'm going to get the exact same point. But if I reduce it and then I have a different S and T, it's just going to get me on a different point, but I'm still on the line in this case. Well, it's the same when we're talking about a plane.
okay, thank you,
Does
ma'am.
that make sense?
Yeah.
Okay. Okay, so here, one thing that I want to do is I want to reduce this. We always like to reduce our direction vectors, okay? And then here, if I'm finding BC, I have 2, 3, 5. So I have 2 direction vectors, and all I need is a position vector. I have so many. I can use whichever ones I want. So which one do you want me to use?
2, 1, -3.
Sure, the first one, why not? And then I'm going to use my 2 direction vectors. Okay. Are there any questions?
Yeah, I have a question.
Yeah, talk to me.
For the second vector, can you do AC?
Yeah, you can. For sure you can.
Okay,
You
so the
can do
values
BA.
would be
You
different?
can do CB. You can do CA. Yep.
Oh, okay.
Yep.
Okay, thank you.
Yeah, no problem. Okay, example 3. Does the point 4, -1, 5 lie in the plane defined by this direction vector? Wait, did we skip? Did I skip an example? I don't think I
No.
went through. We did everything?
Yes.
Okay. Okay, so does this point lie in the plane? What do I do?
So we set the x coordinate equal to like the x components of the equation.
Okay, so
then-
you want to find your parametrics.
Yep.
Good. So we're going to find our parametric equations. Okay, so I would get x equals, go for it. What would I get?
1 plus 3s
Good. And then,
negative s plus 4t.
and then,
4 plus, minus 3t.
good. So there are my parametrics. And now what do I do? So I got my parametric equations. I want to check if this point lies on this line. So this point is what? It's an X, a Y, and a Z. So what should I do next?
Solve for s and t.
Yeah, we're going to sub it in. Oops. Okay, and now you're right. We're going to solve for S and T. So if I look at equation 1, then I can say that 3S equals 3 and S equals 1. Okay, what other equation should I use?
The one with only T.
Yeah, good. I want to use the one with only T. Because now I want to solve for T, right? Okay, so I have S and I have T. Now what do I do? I have S and I have T. Yeah, we're going to sub these values into the second one. We're going to see if it works. Let's see if it satisfies that equation. Is that true? Nope, it's false. So what does that mean?
It doesn't lie on the block.
That's right. It doesn't lie on the line. On the plane. Are there any questions? Okay. Example 4. Find a vector equation of the plane containing these two lines. Okay, again, what do we need to define a plane?
2 lines.
Okay, yes, okay,
And
we
the
do need
point?
2 lines. We need what though? What do we define a plane with? 2 direction vectors and a position vector, yes? Yeah? And I
Yes.
have 1 direction vector here, and I have another direction here. So let's take a look. Let's simplify the second one. If I simplify it, what do I get?
-3, 1, -1.
Or do you agree if I divide by -2?
Yeah.
So essentially, do I have 2 direction vectors? I don't. What I'm seeing here is that these 2 lines are parallel. Right? So what do I want to do? Well, I have a point on this line. Let's just say it's here. And I have a point on this line. I'm just going to pretend it's here. I can find another direction vector by subtracting those 2 points. Is everyone following me? So I'm going to find direction vector M3 now. I need 2 different direction vectors, right? I can't have it the same. And so my third direction vector I'm going to get just by subtracting these 2 points. And it doesn't matter which way I subtract them. And now I can define my plane, no problem. Did it matter which point I used? No.
No.
Good. Any questions? Good. So again, I had a case here where the two lines that they gave me were parallel. Well, that's a problem because they have the same direction vector if they're parallel. So I had to find another direction vector. How did I find the other direction vector? By taking 2 points that lied on the plane. So I have 2 different points that lie on the plane, and so I subtract those 2 points to give me a different direction vector. And I know as long as these 2 lines are not coincident, I'm going to get a different direction vector, right? If these lines were coincident, I don't have enough information to answer the question. Okay.
We can swap S and T, right? Like in the final equation.
Yeah, you can. Yeah.
Okay.
Yeah.
Just
Like
making
meaning
sure.
it doesn't matter which direction vector you use first. Absolutely.
Yeah. Yeah. Okay.
Absolutely.
Thank you.
Yeah, no problem. Okay, example 5. Determine the intersection of the given plane with the z-axis. So for example, find the z-intercept. What's the z-intercept? What does that mean if I say z-intercept? What do I know for sure?
X and
I
Y
know,
0.
yeah, if it's a z-intercept, that means it's intersecting with the z-axis, and that means that x and y have to be 0, okay? So what should I do here? I want to find the point of intersection. Determine the intersection of the given plane with the z-axis. So where does this plane cross the z-axis? What can I do?
Find the parametric equation.
Good, good. So what tips, okay, so why parametrics? Because I have a point here. Yes, I have coordinates of a point here. So if I sub into parametric equations, if I get these in parametric equations, I can sub in that 0, 0, z. And then from there, I can start solving for s and t, right? And if I start solving for s and t, well, then I can solve for z. Okay, so because I have 0, 0, z, what you should be thinking is, oh, parametrics. So I would have x equals 1 plus s plus 2t. Y equals -1 plus 2s. Z equals 2 plus s plus t. And now we're just going to sub in. So I have 0 equals 1 plus s plus 2t. And then I have 0 equals -1 plus 2s. And then I have z equals 2 plus s plus t. Okay, cool. And then here, let's go ahead. So what you should notice here, what can I do here?
So for us.
Yeah, so when I look at these 3 equations, I notice I have 2 variables in the first one. I have 2 variables in the last one. I actually have 3 variables in the last one, but I only have 1 variable in my middle one. So let's go ahead and solve for s. Otherwise, I can't do anything, right? And I see that s equals 1/2. So once I do this, then I can go and sub in and find t. And so, oops, that's not a negative. My pen just did a weird swipe. And so you're going to see that t is equal to -3. Oh, careful. No, me. Over 4. Cool. Are there any questions? Okay, so I still haven't solved the problem. I need to find z. But what can I do now?
Sub in both
Z
of the
is equal-
values.
Yeah, we know that z is equal to 2 plus s plus t. So I can sub s and t into this guy. I want to reference it, so I'm gonna label them. There we go. And so now I have Z equals 2 plus S plus T. Find a common denominator, add them together, and you're gonna get
7/4.
good. Therefore, the z-intercept is 0, 0, 7/4. Are there any questions? Okay, so guys, these questions are not difficult. However, when they're all put together, it's difficult for you guys to realize what you need to do. So it is imperative that you guys do your homework. Okay, very important, because you need to be able to distinguish when to do all the different things. Okay, does that make sense? Are you guys still there? Can someone just talk?
Yeah.
Yeah, excellent. Okay, good. Okay, so I think that's the last example. It is, yes, and your homework is page 459, numbers 1 to 15. Okay, so for the rest of the time, guys, until 3 o'clock, just working on your homework, and I'm here if you have any questions, okay?
Witness, how do you determine if two lines are perpendicular in three space?
You can't, okay, so two lines are perpendicular. Their dot product will be equal to 0.
Oh yeah. Okay.
Yep.
Thanks.